you still in pencils?
Huh?
You still in her pencil?
No, I'm giving it back. I'm saying that one has a little more lead than mine does, so I'll give that one to her. Have a good one.
See you later.
Ashley, did you get a pie? I saw you.
Yes, I did.
What did you get?
I got chocolate. It's so good.
I got a turtle cream. It was so good.
Is that a what?
A turtle cream pie.
What is that?
It has like the crust is like chocolate.
You ate turtles?
Yes, they were amazing. Just kidding. And then it was like
That's cruel.
pecans with caramel and
I'm not a pecan person.
but they were like barely any, and then chocolate. It was so good. Like, don't underestimate it. Okay, go try them. Go try it yourself. It was
I'll
so
think
good.
about it. I'm gonna get another one during lunch.
Oh, me too. Today just went sugar day, okay? Because my
Yeah, I know.
my advisory teacher just bought a bunch of these, and she was like, I don't want them, so I took a Samoa.
Of course, you have to.
And yes, of course. Samoas. Yes, there's 2 left. Don't worry, I didn't eat them all. I handed them out. I've only had like 3.
No.
Mr. Townsend is judging me right now.
Yesterday at practice, I found out I'm not running the track meet today, so I was like,
Why?
oh, I'm eating the pie.
Oh, there you
So I
go.
was like, oh, I can't have that much pie.
Oh, I would
I'm like,
still eat a pie.
That's only one piece, like, not like
Yeah.
three.
Oh, I'm gonna get another one.
She was
for-
silent.
Okay,
She
thank
said
you.
I might do the meat Saturday on Saturday.
Oh, yeah.
So, I was like,
Okay, fine by me.
Yeah.
Yeah.
It's
So,
just too cold tonight anyways.
oh, that's true. It is.
I'm not planning.
So yeah, I'm just
Do
gonna
we
save
turn
this
in
for
the
next
circuit today?
At the end of class, yeah.
Turn what? For what?
Don't worry about it. It's at the end of class.
Are we doing it today though? Are you
What?
working on it?
It's typed out for you if you want to know. The party bell hadn't even rung yet.
I'll circuit.
Oh, finish. Okay, so we're working on it. In class. Okay, good. I was about to say like.
That's the one that you already started.
Weren't there 2
Yeah.
circuits, or am I experiencing them in Delaware?
I have
No,
clue
it
what
was
that
one
is.
circuit, there are 2 pages. That weren't stapled.
Oh, I'm so excited! Spring break is in like 3 days.
I need a break.
What are you doing, Claire?
Costa Rica. Of
Oh,
course, not
gosh.
Costa Rica.
Wait, is it? Oh, yeah, you did. It's with your family. I forgot. Yeah, I remember. Oh, this one's so fun. The beach, right?
Yeah.
Oh, don't even get me started on that. Okay, we're going from XNA to Chicago, Chicago to like somewhere in Germany, Germany to Rome, Rome to Naples, and then we're driving from Naples to our house. And I'm like,
That,
no.
is that it's gonna be like all day you're gonna be exhausted?
Yes, and I don't. Gosh, I don't like commercial driving.
I have one thing that's behind, like delayed, and
Yeah,
then
yeah.
maybe
Oh my gosh, it's so tragic.
it's gonna ruin all like 6
But
of them.
my dad has like planned this, like very much planned this. So it should all be fine, but like the food is awful.
Well,
And if I have to
it only
sit,
takes one delay.
that's true. That's true.
And it brings the whole
Wait, 'cause
chain.
it's supposed to rain on Thursday, and like, let's see if it.
And you want to look at the weather in Chicago up north. They're doing so.
Oh, don't say that. Okay, let's check. So yeah, and I just like don't want to be on the flight for that long. Well, no, it should be fine. It's just gonna be cold. And then, no, that was in Chicago. And then let's look at Zurich. Or Switzerland. I don't even know. Oh, that's in Switzerland.
All right, we've got one new handout this morning, number 103. So since we officially moved on from new content from your last unit, I know we didn't take the test until last time, but we've done a few things that make up this last unit before we're in full AP review mode. So that was area between 2 curves. We started that, and you need a little more practice on it. I'm going to ask you to come back and finish up that assignment here in a bit. We did volume from known cross sections. We started that, and we still need to go back and finish that another time. There is a topic called L'Hopital's rule, which I actually showed to you guys first semester, but I will review it with you before we get to our last big test. And then the last big topic is really in 2 halves. Both of them have to do with volume. And the first method is called disk method, and that's the one we're going to look at today. There's another one called washer method that we will need to look at as well. But we're going to just kind of do a little introduction here. So I'm going to show you basically how this works out and what we're trying to achieve. And then you pretty much know how to do the calculus behind it already. And then I have just one Khan Academy assignment to go along with it so you can get some practice other than these 4 that we're going to look at on the notes. And then the rest of the class I'm going to ask you to work on that 101, which was the circuit over area between 2 curves, because I did not give you enough time to finish it and I did not ask you to do it for homework yet. Okay, so this section is also about volume. So what we do, this is like really the last big idea, even though it's split up over a couple class periods. But the last big idea that shows up in Cal AB is if we take a 2-dimensional shape, which is this area, and if we take that 2-dimensional shape and then we rotate it around the x-axis or around the y-axis or around a vertical line or a horizontal line, we won't do those today, you end up with a 3-dimensional shape, a 3-dimensional shape that does not fit any standard geometry formulas, but with calculus we can calculate the volume of this shape exactly with integration. And so what ends up happening is, if you take a cross section of one of these, so if you just kind of slice it and then look at the outside, you end up with a circle. So really all we're doing is we're putting together an infinite number of circles. So there's one, right next to it's one. We're just stacking up an infinite number of circles on top of each other, and all of those infinite 2D shapes end up making up a 3D shape. Okay, this is supposed to say the disk method. We're not doing the washer method today. The disk washer method is just one more step past the disk method, but it's the same kind of understanding. All right, so let's sketch these 2 graphs so we kind of have a visual of what we're looking at. So y equals 0. Sarah, do you have a pass? Okay. Okay, so we're going to have, when we graph these 2 things, we're going to have a region enclosed by those curves. So that's going to be this stuff that I'm highlighting. This would be the area. But then we're going to take this 2-dimensional shape and we're going to spin it or rotate it around the x-axis, and this 2-dimensional shape becomes a 3-dimensional shape. When you spin that 2-dimensional area all the way around, all those pieces make up a 3-dimensional shape. So here's what you guys need to understand to be able to work these questions. This is the understanding behind it. When I rotate this, I'm going to try to zoom in to try to show this as much as I can. When I rotate this right here, it's going to go around just a little bit because it doesn't go very far below the x-axis. But here, this one's going to go a little bit bigger, a little bit bigger. The circle that it creates be a little bit bigger, then a little bit smaller, then a little bit smaller. So what we are actually going to be integrating is I want to add up an infinite number of circles. So kind of like the known cross-section volumes, we're going to take the area of a circle, which would be pi r squared. Because we're rotating this around the x-axis, it's going to be dx, and the bounds are going to be the far left and far right x values. Now, it kind of looks like this is -2 and this is +2, but this is actually negative square root of 3 and positive square root of 3. You could set those equations equal to each other and solve to figure out where those are. But the tricky part is you need to think about what this radius length is, because it changes. The radius of this circle is not the same as the radius of this circle. They get bigger for a while and then they get smaller for a while. So you've got to think about this radius length, all of these radius lengths. Actually, it might be better to look down. This length, this length, this length, all of the radius of the circle is the y value. The distance from the x-axis to the point on the graph is y. But we need these variables to match up. If this is dx, we need this in terms of x. So we're not going to leave this as y. We are going to take the equation, solve him for x. Oh, well, it's already, never mind. My bad. Instead of y, we'll put what y is equal to, x squared minus 3. So this is basically saying add up all the circles because it's pi r squared, from this x value to this x value, because that's where these two intersect and stop intersecting, and then rotate it around the x-axis. And that integral would tell you how much volume you have. Now, of course, the negative doesn't really matter too much here, but that's the integration. I guess the exact values don't matter, but this is what we're trying to set up. So all of these are going to be created by circles. So all of these are going to be pi r squared. If you're rotating about the x-axis, you're going to put dx and use x bounds. When we rotate around the y-axis, we'll use dy and use y bounds. But the part you really have to slow down on is the pi r squared. You have to look at your picture and calculate what r is. R is not just a number. It changes depending on what x is. This length was whatever y was equal to. So I want you to try that just one time, just to see what parts you get and what parts you don't get. But you do need to sketch this. So try number 2. And then I'll come back and fill in the gaps for what you may not have thought of. And while your graph doesn't have to be perfectly accurate, the better your sketch looks, it might be the easier it is for you to extract what you need out of it. You don't actually need to integrate it or even throw it in the calculator. Just try to set up the integral. Okay, let me intervene here. So when you set up your integral, did you pick dy or dx? Should be dx because you're rotating this about the x-axis. What were your upper and lower bounds limits of integration?
-2 and 2.
Okay, and I'm guessing she's getting that from the far left and far right x values. So this is the region trapped between those two graphs. This would be the area that you're going to rotate. And then you're going to turn this in this direction. So you're going to have some small circles on the ends, but as you rotate it, the middle part's going to have bigger circles, but because we're adding up an infinite number of something, that's why we're integrating, because they're circles, it's pi r squared. So really the last thing you need to be careful about is what is r, since r changes. So I look at all of this, the distance from the x-axis to the function, distance to the x-axis to the function, we always call that distance y. But how did you know not to leave y here?
Because it's the dx.
Right, you need these variables to match. So don't call this y, call it what y is equal to. That integral will get you that three-dimensional volume when you take that two-dimensional shape and rotate it around the x-axis. So the setup is actually quite a bit easier than you may expect because it's always a circle, always pi r squared. You just have to kind of rely on your picture a little bit to get the r part correct. Okay, I want to do one more example for you and have you practice one more, and then again the Khan Academy it's not a hard one or anything, and it's just one. I want you to just get a touch of practice on your own. But now we're going to swing this around the y-axis so you can see what's different there. So first off, you're going to need some kind of a visual here. This is supposed to say x equals on these. But we've got y equals, x equals, and negative x plus 8. So this would be this is the region enclosed by these two graphs. It's a two-dimensional shape. But now we're going to swing this two-dimensional shape this direction around the y-axis, and so it's going to change some of our work here. Now, same idea. When I swing this little bit around the y-axis, it's going to create small little circle cross sections. But as you go down, the cross sections will be bigger. But you really need to, you don't have to draw in a ton of circles, but you should draw in a couple of them. Kind of helps you see that you're swinging it the right direction. Now, the difference is, because it's rotating around a vertical line, like the y-axis, we're going to do dy. Because we're doing it that way, we're not going to look at the x values, we're going to look at the y values. So, the bottom to the top. Now this one you would actually get lucky because they're the same, but they're not usually the same. We're still adding up an infinite number of circles, so pi r squared. But once again, the part where you have to slow down on, the rest of it comes pretty quickly after you do a few of them. But the r just depends on the question, the direction, the shape, all kinds of stuff. So looking at my picture here, I draw in a couple of these r's for me to see. What do all of these purple links have in common? What could we call all of those? Right, the distance from the y-axis to the function, we call that length x. So you might be tempted to say that r is x, and technically it is, but you need these variables to match up. So we're not going to leave it as x, we're going to put in what x is equal to. So you got to go down here, subtract the 8 over, and multiply both sides by a -1. That integral gives you the volume of that three-dimensional shape. Now in this one, I'd never really thought about this, but this one's kind of silly to do calculus on, because really if you did this, you see how this would really just make a cone? And you can like see the radius length, and you know the height. So I guess you could get away without doing calculus on this one, but usually they're not rigged that way. Okay, so what I did different, because it was around the y-axis, was dy. I needed this to, my radius to be in terms of y, so I had to solve for it, and my values here. Lower to top, because it was vertical, dy. So give that a shot on question 4, see how you do. And if nothing else, try to figure out what you might need to ask about. We'll check that and then do a couple quick practice questions out of Khan Academy. Most of the Khan Academy ones just are asking you to set it up. So I will help you get that knocked out for a couple easy points, and then you have the rest of class to finish up the area between two curves, which I will also help with, but I want to make sure everyone finishes the Khan Academy first. Okay, so again, the picture is pretty helpful, so you need to be careful that you sketch those correctly. Identify the area that you're rotating, the two-dimensional shape that you're spinning around to make a three-dimensional shape. Even though you don't have to draw in a bunch of circles, and obviously you can't draw in an infinite number of circles, it's still good for you to draw in a few of them. It kind of helps you visualize the shape, and it's going to help you pick out the R value correctly. Now, because we did this one with respect, revolved it around the y-axis, this is why I did dy, and you should have y values here. It goes as low as -5 and as high as 0. So if you said 0 to 5, you were looking at x values, which is good if you're rotating around the x-axis, but not the y-axis. Why, though, am I always doing pi r squared?
Because you're using circles.
Right, we're just dissecting this three-dimensional shape into a bunch of circles. So all of these, even when we do the other method, the washer method next time, we'll still be using circles. So pi r squared, you've got a couple circles drawn in here so that you can visualize the radius length. Sometimes it's 5, sometimes it's 0, sometimes it's 1, but this length is always called x, the distance from the y-axis to the right. But you need these variables to match up. So don't leave it x, solve for x, and call him y plus 5. That integral is what would get that volume. So again, these are kind of hard to visualize, but you don't have to do them perfectly to be able to do what you need to. So the main thing I can tell you to slow down on is the radius length. The radius length is the trickiest. Okay, anything on the notes y'all want to ask about before we slide this out of the way? Okay, so quickly go ahead and knock out the one Khan Academy. If you need to do any scratch work, go ahead and number the scratch work as 104. As you guys know, I don't normally need that, but just in case I do. I think most of those questions are just asking you which integral would be the setup, but you might actually need to integrate one or two depending on which questions you get. So I will come around and make sure that you guys are doing okay with that. Yes, ma'am.
I'm selling pies at 11:40.
Okay, do they have you marked yet? don't. You'll need to make sure that they
Okay.
update it. So if you miss one on Khan Academy and you click the get more help and you're not sure what you did differently than you were supposed to do, comment over and let me help you. Guess I can see you from over here. Anybody need help yet?
Right. Yeah, so they're wanting you to say, assuming this number's right, 2/3 pi, don't multiply pi, just put pi in your answer.
Again, the scratch work might make it a little bit easier. I can see some of you are like scrolling up and down to see the picture. which is fine if that works for you, but to me that would make it a little bit harder, so. And then even once you get 100 on it, if you don't feel like you understand why you're getting the correct answers, you still probably want to go ahead and ask. Because the last thing that we do, the washer method, is basically this exact same thing with one more step. So it certainly helps you understand conceptually what's going on. I'll be happy to help with the area between two curves circuit for those of you as you finish the Khan Academy. But I'm going to ask you to wait for questions on that until everyone's in the Khan Academy.
How do you like do this in terms of pi?
So I would just work this out manually. So if you have a calculator, you let your calculator do it, or do it by hand. And then in terms of pi, it just means don't multiply pi in, just leave it in your answer.
Okay.
So like right here, if you just left that off, you're gonna get a different number, hopefully 46/3, and then you just put pi in your answer. So don't multiply it.
However, if you do get stuck on one, I know those are all worked out on my website. So if you're stuck and you really don't like to jump out of order on those, you're being impatient, then I guess you can use the website for a minute until I get everyone caught up. Yep.
Oh, and you just plug it in.
Yeah, I put it in Google Classroom.
Just in case.
checked out, so.
Oh, it's just moving to.
I know some of you got further on the circuit the other day, so I would like you guys to turn this in today, but I'm going to ask that you put it in Google Classroom if at all possible. So if you're one of those people that got a lot done with it last class and you don't need much class time to finish that up, then you should be able to turn that in Google Classroom, no problem.
So I took out the pi to get terms of pi, but it's still not like below. Like, do I just put 15.3 repeating pi?
Well, it's probably going to want you to do it as a fraction. So you get a new calculator?
No.
So if you know how to change that to a fraction,
Okay, so then the
hit
top
math,
one will be
enter, enter. That tells it to change it to a fraction. It probably wants 46 over 3 times pi.
Okay.
This probably doesn't want the decimal.
Is this the same stuff as like this one? Or
Yep.
did this on the
-1
Yeah,
is the
same
bottom.
stuff.
And then
Oh, is it? I mean, what do I
Times
have?
five.
I don't know if it went. Can we use a calculator or can we just do it by hand?
it's probably
Calculator's
I think
fine.
it has to be X by some.
I think it's probably a good idea
Yeah.
to, if
What
it
does
looks
say?
not that bad, to maybe do it by hand just for the practice, but I'm mostly concerned with y'all just knowing how to set them up.
Yeah, 1.
So the top is the 8 over 1 over 4 plus x squared. Minus 4. Right? Yeah. I think that's what you do.
I'll put it in.
Okay, y'all got about 3 minutes till the lunch bell, so try to at least finish up the one you're on. I figured out your mistake. You had me look at that question for several minutes. One of the answers is 25. You did it right.
None of them are 25.
2 pages. You don't have a second page?
No.
There's a second page.
Oh, is it over here?
Wow.
There will be extra copies of it.
Yeah.
I'm like, I know this question's easy, but I don't know why it's wrong.
I did. I got. I think it's like a cookie dough. Cookie dough.
I feel like we should be celebrating Pi Day here. So,
Yeah, y'all didn't bring me any pie.
Would you like one? I have change.
No.
I have some dollar bills.
I literally have like 7. Look. Look at
Oh,
this.
you get $17.
Well, I have 18. I gave one to like the friend. See, whenever you break your money down like this, it's just so much easier to give it away, you know?
No, yeah, that happened.
Like, I was just like, oh.
Like, I had to pay the rest of someone's NHS dues for them. Like, I'm not even in it. Like, do you
Oh.
have some money? I was like, yeah. And then it was all in ones, and so then people were just asking for them.
That's so sad. I know, exactly, that's how it is.
Okay. It's fine. It makes it feel like I
Should
don't
never
like
loan money
It's
to
like-
people.
Do what?
Should never loan money to people.
I know, they're not gonna pay me back either, they never pay me
But it's
back.
just
Yeah,
so
see, they don't pay you
dollar.
back, and then
They
you end up
honestly
mad about
can't
it.
money.
So then you're out of
You
money
can't,
and
you
you're
just
mad.
have to expect, so you just have to expect that you're not gonna get it back.
So you have to.
Yeah, I just kind
you
of
have to
expect
take
it
it
as a
down
gift.
on your notes app and then remind them every single day.
Oh,
They don't really
no.
care.
This was
That's what I
like,
mean.
I was giving $1 to my friend, like, I'm not gonna make her pay me back.
Yeah.
I don't care,
You
it's just
give
$1.
it without the expected back.
Okay, I guess the bells are still turned off here. I didn't see anything in the announcements about testing or anything, but if you did not finish up the Khan Academy, please do that first. I do expect that one to be done before you guys leave. Those of you that are pretty far through the circuit and can finish in class, go ahead and turn it in Google Classroom, please. And if you don't, I'm going to ask that you do that for homework. I am going to quickly say, though, on one, I know I have all of these questions worked out at the end, so if you end up not finishing in class and needing some help, there is some help out there. But I think when you get to question number 10 on this circuit, you have to remember the derivative of inverse tangent, which I have shown to y'all twice for previous circuits, but I've never said you had to know it. But there is one question where you're trying to integrate this and go this way. So since I've never told you you had to have that memorized and ready to go, and again, I think it's number 10, box number 10, where you need that. So
Yeah, but I should put my calculator. Is that? Are we supposed to be doing these by hand or are we supposed to?
You can do it in the calculator, that's fine. Yeah, I didn't think of that, but
Did you say this is due next class? Or,
the Khan Academy is due before you leave.
right, I'm talking about that.
This, if you don't finish it in class, then you can turn it in before next class.
Okay.
Okay.
But it needs to be in Google Classroom. I won't think to ask for it.
No. I think I put my X. Yep, there we go. I just put my X in the last one.
Oh, I guess I should also add, maybe this one wasn't as important, but remember for a lot of these area between two curve questions, you want to think of it as top minus bottom. But if you're doing something horizontally, I think there is one or two questions where you need to think of it as right minus left instead. So, since it's been a few classes since we talked about that, just give you a quick little reminder there.
Yeah, I got 0 to 2 for that. But what if it's to the? Oh, I can make 0. 0 to. Yeah, it's 0 to 2. I guess the top is square. Wait, I'm on the wrong one. Oh shoot. I was like, can we go through the top one? Yeah.
So you have negative x plus 1, negative plus 1 minus x. Basically the same. It's 4/3. Oh, 1.3. Wait. What we already did. So what happened? I'm making this in my calculator and I'll see what it takes you. Hold on, let me solve this. Find out 1.3333375. Which is basically 4/3, right? Yeah. But it's 2 9 9 8. That's like 1.1. Yeah. So what do we do? How necessary? Okay, so let's just for x minus y equals 1. Negative y equals negative x divided by negative y equals x minus 1. We got that, right? So then plug that in y equals x minus 1, you get y equals negative cx minus 1, which is negative x plus 1. The balance is 0 less 2. We're supposed to do the x-axis, right? No, I think I would have said if we can y axis, I'm just gonna try the y-axis. What about the bound? The bound would make sense. Yeah, that's true. Oh, the bound that's around 0.9 or something. Because it's not 1. Yeah, that's not 2. Yeah, so we have a little bit of an issue.
You know, okay.
So we got, I think we might have got out one somewhere.
That's my number 12,
Okay, because,
but I don't get that answer.
did we set that up wrong?
Why did you put this one first?
Because it's like, on the tip.
Okay, but if you're thinking left to right, you need to do right minus left.
Oh.
But like, how would
That's
you
not,
know?
that's not on top.
How would you know whether or not to use
I guess,
one or
yeah, we
Yes.
thought that was on top.
Well, I graphed it.
Yeah, we grabbed it.
Well, yeah, but
Boundary
that's
area.
that's on top.
So that's what we thought. Right? I mean, it looks on top.
Well,
I
no,
guess.
from here to here it's on top,
Mhm.
but from here to here,
There's been really two.
because it exists down here too. This is below that.
Oh, that was.
Sometimes this one's on top of that, and then sometimes that's on top of that.
So in that case, you use left to right or right to left.
Right minus left.
Oh.
If there's not always the same one on top and the same one on bottom, you probably gotta do right
Minus
and
left.
left. Yeah.
Okay. So 40
I help?
x minus 1 plus minus
Something I can help with?
square root of x over 2.
I need help with your 8.
Number 8. Let's see. That is not my number 8. So let's backtrack. Where's the number? Okay, number 2, 6, 7. I got everything else right number 7, so let's worry about that first. So on this one, since you need to do top minus bottom.
Yeah, me too.
I don't know if you put much thought into that, but I
Let's
top of the
hitting?
cosine, bottom of the cosine. So that's
What?
what we did.
Who's hitting?
I don't know, but.
So it should be square root of 2 minus
Because 47 divided by 12.
See what that
Maybe I
means.
remember
It's
nine
not
twelve.
that decimal. No, he said,
Can I help?
he said they were right, because he said that our number 12 is the.
Well, yeah, but then
I guess we did something else after we got back, but.
yeah, what if we did that? Wouldn't that be awful? Don't we
Well,
have
this
to-
is positive for something,
Oh, that's true.
so it's something I'm saying.
Maybe something else equals negative 4/3.
I mean, I guess 9/8 is close.
That's
But
what
one
what
is
you want.
positive.
Yeah.
None of these are negative, they're all positive.
Oh, that's true.
So.
We need this.
What is your?
Well, that means we're done. So that can be
There's no way it's that. That's positive too, it looks like. Maybe not.
We'll do that too. Yeah.
Yeah, me too.
I'm also an hour late every
Times 4x. And then
It makes sense though.
I just wake up at the same time, I just feel more tired.
Really?
Yeah. Or like,
Oh well, I don't get up. I just kind of.
oh yeah, you can. You have slow mornings.
But like,
we'll see if it
if I wake up at 6, I have 2 hours to get 2.5 hours. I have to go to school.
Yeah, then you don't wake up at 6.
you go.
Yeah, but then like if I'm like, oh, you know, I don't feel like getting up right now, then I can wait another hour. So then I don't feel rushed to get up.
Sorry, can I-
Well, no, I'm just trying to get as much as I can, and then once it goes off, I'm not bad.
No, racer?
So I'm taking.
I'm not a man in my business, so he's okay.
So we still aren't getting.
Yeah, we got negative
We got
4/3.
negative 4/3, which is not any answer for us. It's
What box is it?
12. It's the same question. We said it the other way. But just changed it from positive to negative.
Let's, I will start it with you until we figure out where y'all went different.
Okay.
Okay, so I sketched these graphs. This one's a little bit easier for me to keep up with. So, there's that one. This one, let's see, we divide both sides by 2 and take the square root of both sides. You have to do plus or minus. Square root of both sides plus or minus.
Yeah.
I don't know if that's going to make much of a difference. But I still don't know what this graph looks like, so I would have to plug in a couple points. If x is 0, y is 0. Let's see, if x was 2, this would be 1. So that would be plus or minus 1. Maybe 4. No, that would be square root of 2. I don't want to do that. 8. See, I'm trying to think of numbers that'll work out nicely. 18 divided in half would be 9. So plus or minus the square root of 9 would be plus or minus 3. So it is going to grow very slowly.
Yeah.
If
we
you-
got that.
Okay? So you're trying to figure out this area. So again, this is what I was saying about you can't just do top minus bottom here, because right here the purple is on top of the red, but then over here the red's on top of the purple, since there's more than one part of the purple. So that's where I would try to do the right minus left. Okay, and then which one of those functions is always on the right?
X minus 1.
X minus 1, okay. This is right. Subtract left. And left is what?
1/2 x. Square root of 1/2 x plus or minus.
Alright, well technically plus or minus, but I think this is gonna be the issue here. Because we're doing this,
Minus, we need plus and plus.
if you're doing right to left,
Mhm.
right to left,
Yeah.
this needs to be dy.
Okay.
No?
I mean, that's the first time hearing, but okay.
Well, if the x bounds determine when you do,
Yeah, I mean, I guess that's it, cause yeah, we put the x bounds in.
okay, did y'all do
Zero to-
did y'all do -1 to 1 here, or did y'all
We
do?
did 0 to 2, we did x, cause we did
Okay.
dx. So that's what we did.
But you're doing this. This is when you're doing right minus left. This is horizontal, so we need this to be. That's what switches the rules from dx to dy.
Okay.
And then you should use y bounds. Except my graph's not great here because this isn't actually -1. This is -1/2. And then because of this, you don't want these to be in terms of x. You want them to be in terms of y.
Okay.
So this would be x plus 1. Or, I'm sorry.
I mean, it makes sense now. I just didn't think to decide that. Like on the other questions, it would say x to y x.
Yeah, that makes sense.
So I just.
But you need these to be in terms of y.
Yeah.
So you got to solve those for y, which is good because right here you can really put it in plus or minus, which does make a difference.
Yeah.
But I will tell you on this one, I ended up with 9/8. So when you think you're done, it should be done. If that's not enough, I can help guide past there.
Yeah, -1.
So let me know what you get. Oh, it's 1 plus. Okay.
Yeah, I got s- This one looks like. Yeah. There's 2 pairs. And then some.
So the first one. Is this one extra big?
That's it. You done? Okay. I didn't read this.
Okay, so this one. Even though this one's top,
Find
right?
2 areas. You do that one, you do that one.
Yeah, and then you add the
So which one you want to do that one?
This one.
You wanna do that one first?
Yeah.
So you want that, that'd be right.
I don't know, 'cause I feel like you have to keep them the same. We'll just put this one on the top. Top and bottom.
it's not always on the top. So you would have to use right left. But like, if you use, I don't know where you can use right left. Okay, we'll try it.
It's -8 to 0. Is that always?
Oh wait, but then you have to solve these questions. I don't wanna do that. Let's just do top bottom for both of them. So the top will be x cubed. So -2 to 0.
Yeah.
I'll do number 7. Sure. So, number 7, write your linear graph. So which one of these is
Zero, though.
on top? That's the cosine.
That's
So,
true.
always top minus bottom, unless you gotta do right minus left. So, you're gonna need cosine minus sine.
The other one.
Yeah.
And you can subtract those. Yeah, but I disagree with the upper bound you're doing. You don't have. It's from x equals 0 to x equals
Yeah.
where those intersect. Nope. On the unit circle one.
If cosine's the x value and sine's the y value, the first place that they're the same is right here, pi over 4. So you need to integrate from 0 to pi over 4, the top function minus bottom function. And then that should get you the answer.
Number 8, how do you know to use, like, if you use x or y?
You mean like top minus bottom or right minus
Or,
left?
like, for, like, the bounds, because, like, it doesn't say, like,
Well, since you always have the same function on top and the same function always on bottom, do top minus bottom, and that would be dx.
okay.
And since it's dx, you should be using x values.
Okay.
Let's talk about it. I don't think so, because there's no negative. So we need to talk about
Yeah, see what you need to, oh wait, no, you'd be fine. Oh, yeah, you can just square it. See, I'll do that.
So just be y squared equals x equals, okay. So
So
x equals y
Wait,
squared.
we should find the y balance. Look at the y
Oh, oh, I gave you the wrong balance the first time. Maybe that's
balance.
why.
0 to 2?
No, it's 0 to 1. I
Okay.
think. Wait, let me just look. Let me just make sure.
Let
Let me just make sure. Yeah, it's 1.
Okay, well.
I was
I should
looking
be
at the
doing
y.
calculus.
Yeah, you should.
I just can't ever do it fast. And you always have an answer.
But I always get it wrong.
You do.
Okay, I got 0.83 this time. But I don't think that matches any of our answers.
Well, we only have 7, 6, and 100. Actually, 196 there is.
That's like.
With 65.
Yeah.
Never mind. See,
Yeah.
I can't do that stuff. I would like totally think that.
Oh.
Without my calculator.
Okay, so what is this then? 7C. Okay, so let's just try the y balance.
Okay.
So, be 0, 2. And then be, which,
It is 2 for sure.
yeah, it is. And then the right bound, or I mean, right would be, see, I don't know.
I do on that other one. We put, yeah, it'd be 2 minus x or whatever.
Is
that
the right? Is on the right?
You make it x equals 2.
So it'd be negative y plus 2 minus y squared.
To be 2 minus y. Right?
Yeah. Yeah, yeah.
So 2 minus y minus y squared.
Negative 2/3. So that's definitely not right. Wait, you plugged in 2 minus y minus y squared and the boundary is 0 and 2.
I haven't put it in the calculator yet because I can't type it as fast as
Well, I mean, I think that's what it looks like. I just put x instead of y.
Yeah. What's the answer?
Here, let me just make sure the balance are 2.
This is the limit. It is.
Yeah, so it's not.
Oh, did the first. Are you sure 0 to 1 as?
Yeah, it is. Right? I think no, I literally did it. It was 1-1. Right? Isn't she right?
I'm struggling with my calculator.
Oh.
It's just, I'm just trying to find that x. The other x.
Okay, so our possible answers.
Is it 0 to 2?
Yeah. No, we already tried 0 to 2.
Yeah, but
You're not wrong. Well, we don't need it.
where did you get 0 to 1? Because I think it's 0 to 2.
Signatures, intersect,
Oh no. Oh,
that makes sense though, right? Go x.
yeah. Oh, we got the y one. Right?
No. Because the y would be 0 2, which is what we already did.
But that's more. Because it's no, so it'll be 1. It's 1. 0 to 1.
What?
The Y.
No, because it goes up to here.
Just goes to that intersection here.
No, it goes here.
Oh, so how do you go about that?
Yeah, so that's the Y, 0 2.
Oh, so then why just do the intersection of X and go all the way to?
Well, on this one, because this is where it stops. Like, this is what it looks like. That's what, like, the shape we're trying to find is. So if we go, we're trying to find the X, so we have to go to here. We're trying to find the Y, we go up to here. So we find here, and we find here. There and there. So that's one.
I thought we were supposed to, I thought we were trying to find this area.
No! We're trying to find this area. Like, right here. Because it says and Y equals 0. So we're trying to find it here. Y. Right?
I don't know.
We're confused again.
I thought that was the area under both curves.
I thought it was this.
No, but that's not under the curve. That over there is not under the curve.
But it says when Y equals 0. This is when Y equals 0.
Which does it?
Yeah.
Yeah.
Okay, hold on. Give me 2 seconds. Or I'm gonna forget this.
But
Hey James, which one are you on?
15.
Okay, no. Wait, how'd you get 14? Like, how'd you set it up?
It's also closing by Y equals 0. So it's not negative 2 to 1.
Well,
It's
you
0,
can
right.
happen in whatever cause.
So did you
did
put
that.
0 to 1,
Put it
2
in
minus
parentheses,
x
though.
minus the square root of x?
oh, it's the whole thing.
Yeah.
No, mine's x squared. Or I did it in y's.
You can do in block.
Oh.
Because I did right to left. Because it's
So there's
it's like
and then.
they
No,
don't
that's
really.
not-
There's not really like a top because they intersect in the middle. So I just did right to left instead.
Oh.
Did it in the
That's
y's.
what I said, 0 1.
So I just did I did 2 minus y minus y squared.
Okay. Okay, thank you.
Okay, figured out.
Okay. So we're trying to figure out this area, like you were saying, right
Yeah.
here. Well, how would you know? I don't know.
Just trial and error and figure it out.
Wait, that y is 0. It goes across like this. I kept thinking it goes across like this. That's x equals 0.
Oh yeah, sorry.
Okay. So it'd be.
Okay, we've got about 3 minutes here, so let me make sure that you know what is expected of you. I do want you to turn in the 101 circuit, the area between two curves, before the start of next class. So that is opened up in Google Classroom. I have videos of all the last ones, so please do your best to do that tonight, so that if any of those videos are not sufficient, or if there's something in there that you're not sure about, you can stop by during advisory tomorrow and I could help you out with that. Secondly, if you participated in the ACTM, they did finally release the test with the answers and stuff, so if you kept your test, you could go and see which questions you got right and wrong. Or if you didn't participate in the ACTM, but you were interested in what it looked like, how hard it was, what types of questions it was, I am posting it to my website. There's a section under calculus for ACTM stuff. So if you're interested in it, but you didn't get a chance to go, then that is going to be there here in just a few minutes once I finish putting it to the website. And then finally, kind of silly, but what was the connection between the daily meme and class today?
Volume.
Yeah.
I was gonna ask you.
He's turning the volume up. Yeah.
Oh, yeah. I was gonna ask you, but then I was like,
More volume.
All right. I guess the bells are still off. Y'all are free to go. Have a good day.